Okay, what is the use of a VT graph and what are all the quantities we can obtain from velocity time graph? The four quantities are average acceleration, instantaneous acceleration, displacement and distance. Let us see how to get them. First of all, average acceleration. You know, average acceleration is defined as change in velocity divided by time taken. That is our basic definition. So, let me consider a general curve here. The steps are like this. At time t1 find the velocity v1. At time t2 find the velocity v2. We did that. So, v1 and v2 are the velocities. And by definition, average acceleration is equal to change in velocity divided by time taken. Change in velocity is v2 minus v1 and the time taken is t2 minus t1. A fairly simple thing. So, to calculate the average acceleration is change in velocity divided by time taken. Next, let us get instantaneous acceleration. Again, here is a general curve. The first step is to find the point which corresponds on the graph. So, this is the point or this is the time instant t1 and let me see what is or where does it meet the curve. Then I will draw a tangent at that point. So, a tangent is drawn at the point under consideration. Then what is the next step? Find the angle theta that the tangent makes with the horizontal. So, I measure this angle turns out to be theta. Which angle? The angle between the tangent and the positive x axis at the intersection point. Then you know that acceleration is equal to slope. Slope is nothing but tangent, that is tan theta, or instantaneous acceleration is tan theta. Thus, if it is a curve, the instantaneous acceleration by definition goes on changing, magnitude is different, while if it is a straight line, for example, if VT graph were a straight line, it would have been constant all along. Okay. What next? The next is how to calculate the displacement between any two instants. Suppose we have a VT graph like this and let us assume that this is a curve. The area under the VT graph gives us the displacement. For example, if I want to calculate this displacement, I will calculate the area. So, area bound gives us the displacement and areas above the x axis are taken positive and below the x axis they are taken with negative sign, and we add all the areas to find the resultant displacement. For example, if we consider a VT graph in this form, some arbitrary representation, something like this, then these two areas are taken with positive sign and this area is taken with negative sign, this area is taken with negative sign. So, this is A1, this is A2 with a negative sign and this is A3, and this, therefore, the net displacement S is equal to sum of the area A1 minus A2 plus A3. Well, how to calculate the distance covered between two instants? The procedure is very similar to the previous. We obtain the area. However, all the areas are taken with positive sign. For example, if I consider the same VT graph, if you look at this area is A1, this area is A2 and this area is A3. Then the net distance travelled, total distance travelled is A1 plus A2 plus A3. A1 plus A2 plus A3 gives us the total distance travelled.